This is video 1 for Unit 2 on Measurement for Chemistry 1. So you should have this in your packet of information. It says POGIL Introduction to Significant Figures. So we are going to work down through this, and I will tell you to pause and complete different things as we go through this. So what we are going to be talking about is using instruments and how we read instruments in science, because anytime that we use an instrument, there's going to be some kind of uncertainty to a measurement because we can only read out so many places. So if we look at our first thing here, we can see that we have model 1 with ruler A, model 2 with ruler B, and model 3 with ruler C. So I would like you to pause the video and go ahead and answer the questions. What distances can you be certain of on model 1, number 2, number 3, A? And then if you turn the page over, and I'm sorry about the stapling, you can stop. So, well, actually go ahead and continue and answer. Read this up at the top, look at model 4, and go down to the stop sign. So go ahead and pause, and we will go over these. Welcome back. So what distances can you be certain of on ruler number 1? Well, if we wanted to measure this object, we only have 2 measurements. So you can only be certain of 0 centimeters and 10 centimeters. Everything else we would have to estimate. So these over here are all estimations. So we can only be certain of the measurement 0 and 10. For model number 2, we have a little bit better of a ruler. So with this, what measurement could we be certain of in this one? Well, any whole numbers between 0 and 10 centimeters. So these are marked off in ones. So the only measurement that we could be certain of is the 3 in all of these because we know that it is a little bit past 3. So we can't be certain it's 3 point what, but we can be certain that it's at least 3. This ruler, now we put 10 lines in between each of the 10 lines that we had up here. So it's an even better ruler. So were the students able to agree on any single value for any of the digits in their measurements using a new ruler? If yes, what values do they agree on? Which digits? Well, they can agree on the ones and tenths places. So that would be 3.2 centimeters because it is at least 2 past that. So if we turn the page and we look, it says, hopefully you read this, when humans are measuring or use measuring instruments, variation is expected. Everyone will estimate differently between marks on the instrument. On the other hand, digits that are certain based on the marks on the instrument should not vary from person to person. So again, here we have these. You might want to say digits that are certain should not vary from person to person. That's an important statement. So number 4 says the measurements taken in models 1 through 3 have been combined in model 4. The measurements that follow the rules of measurement agreed upon by scientists are in the valid measurements column. Those that do not follow the rules are the invalid. For each valid measurement shown in model 4, yellow highlight the certain digits, if any, and circle the digits that were estimated. Well, if you don't have a highlighter, just put a box around the certain digits, if any, and circle the digits that were estimated. So I'll put a little key up here. Box is certain, circle estimated. So in this first one, everything is estimated. These are invalid measurements. So up here, well, we said that we were certain that it's at least 3. So the 3 in each one of these is going to be certain, and these are all estimated. And in this one, the 3 and the 2 in each one, and the last digit is estimated. So down here, it says, based on the examples in Model 4, circle the best phrase to complete each sentence below. So in A, in a valid measurement, you record 1 estimated digit. In a valid measurement, the estimated digit is the last digit in the measurement. So our next set, we're going to look at a couple more rulers. So it says when a measurement is recorded properly, all the digits that are read, which are certain, and one estimated uncertain digit are called significant digits. The number of allowable significant digits is determined by the marks or gradations of the instrument. Sometimes a 0 is the estimated digit and must be recorded. So if we record the length of the wooden splint to the proper number of significant digits, we have to have all the certain ones and one estimated. So the certain digit in here should be what? Go ahead and do 6, 7, and 8. You can pause the video and we'll come back and answer this. So welcome back. Record the length of the wooden splint to the proper number of significant digits. You should have 7.0 centimeters. This is the certain digit, and the 0 is estimated. Now, if you look, it's pretty much on the line, but if you had like 7.1, that is estimated also, so that would be a valid measurement. This one down here should be a little bit more exact. So it's right at the line, so 7.00 centimeters, where these two numbers are certain, and this last one is estimated. So now, question number 8. Question number 8 says, when using an electronic device such as an electronic balance, the measurement displayed on the screen is assumed to have one estimated digit included. In fact, you'll often see this estimated digit changing rapidly because there is fluctuation in the estimate. Explain why it is important to record the 0 in the measurement shown on the right. Well, the reason being is we always make sure that we have one estimated digit, because that is what we include in our significant digits. So go ahead and complete pages 4 and 5, which is this, through number 12, and stop. So go ahead and pause this, and then we'll go over it. First paragraph, when working with measurements, it is important to know which digits in the measurement are significant and which are not. Non-zero digits are always significant. So that is an important statement. However, zeros can be tricky. Some are significant, others are not. This activity will help you learn the rules for determining whether a zero digit is significant or not. So for number 10, it says, for each balance in Model 1, circle the phrase below that best describes how closely the mass can be determined with that balance. So if we look at the Econo balance, it is rounded to the nearest 100 grams. So in this sample, that means that if we look at the range of values that it could be, we could go the whole way from 50 to 149 grams, and that would be how it would be rounded. So even if it was 55 grams or 100 grams or 125 grams, it is going to be rounded to the nearest 100. So that isn't a very good balance. The next balance, you can see that our last certain digit is the 4, so this one's rounded to the nearest 10 grams. So that takes that range and makes it a lot smaller. The Balance Pro, we have 3 certain digits here. So we are rounding it to the nearest 1 gram. So whatever the value is after the decimal point is used to round to that 3. And then the X-Acto balance, we have 4 digits with the last one being estimated, so it's rounded to the nearest 0.1 grams. So which of the following balances is the best quality instrument? Well, that would be the X-Acto balance, because it measures to the nearest 0.10 grams. So it takes that range and makes it a lot smaller. So this would be like a range of about 1 gram total from either side, whereas we had a huge amount, almost 99 gram difference between for the Econo balance. So the exacto balance is a lot better. Number 11. Number 11 says rock C is placed on the econobalance. The balance reads 200. Does rock C have a mass larger, smaller, or is it the same as sample A, or is it impossible to tell? So we are on the econobalance. It is actually going to be larger, but it's going to be really hard to say what it is because this range is at least 150 to 249 grams because it would be rounded. So the mass will be somewhere in there. And if we looked, if it reads 200, that rounds to 200 and that rounds to 200. So those are the minimum and maximum values that will round to 200. So before we had between 50 and 149 grams, so mass C has to be larger. So does rock C have a mass larger or smaller or the same as rock B? Well, it is impossible to tell using that balance because it has the same possible range of values due to rounding. So we would have to use one of the other balances to say whether it is larger or smaller. So the mass of rock C is then measured using the other three balances. The results are shown below. So if we look, based on this additional information, does rock C have a mass larger, smaller, or the same as rock B? Well, is it going to be larger, or is it going to be smaller, or impossible to tell? So if we look, rock B is 177.1 grams on the exacto balance. Rock C is 177.0 grams. So this range is 176.5 to 177.4 grams. So all of these round to that value. This one is 176 or 177. Let's try that again. So for rock B, which read 177.1, our range is 177.05 to 177.14. Those will round to 177.05. For rock C, which measures 177.0, we could end up with 176.95 to 177.04. For our values, those would all round to 177.0. So for this one, we can actually see that we have the exacto balance being the deciding vote. And we can see by the ranges that rock C is smaller than rock B. You'll have to go to the next video to do the rest of the activity.